Communicator can be configured in 3 different ways. We can configure it in development mode, which is the default mode that we provide out of the package that you've downloaded. It can be configured in distributed mode, which is designed for production deployment. And then it can also be configured in standalone mode, which we'll talk a little bit about later, but doesn't utilize these infrastructure provided by Communicator and just involves the streaming application. So first we'll talk about development mode. So the idea behind development mode is to provide an out-of-the-box experience and quickly prototype with Hoops Communicator. So in the previous modules, when we did the viewer sample, the viewer exercises, we were using development mode. And the idea here is that there's no additional web server or configuration needed. It simply lets us run Communicator as a standalone application on our own machine. And we see here, all of the components of Communicator are local to our own machine. The model storage is simply our own file system. The development file server is provided by the server executable. And all the processes that are spawning are just simply existing on our own machine, talking to the same web browser. And the one thing to note for this deployment is that this isn't for production use. It's simply for testing things out and working with the package out of the box. So distributed mode is the most common use case for Communicator. And in this mode, we have one server application per server instance. So what that means is that every time you create a virtual machine that's going to be a viewing server, you're going to have this entire deployment on each one. So each viewing server is designed to be independent of all other viewing servers so that you can add and remove them as necessary. Now, what this means is that all the communication with this server is going to be done in a generic way via REST. So if we look at this diagram, what we're going to do is we're going to trace the workflow of a client connecting and trying to view a model. So the first step is client 1 is going to connect to our web application server. So this is running our Python application or Java application. So the web application server is going to be responsible for providing business logic, making sure that the user is authorized to view this file, etc. And then it's going to communicate with our Communicator server application in order to provision the resources that the viewer is going to need for that particular session. So it's going to make sure that things like the model is available on this particular server. So it may need to pull this model out of model storage and transfer it to that viewing server. Once everything is in place, what's going to happen is that this client is going to connect to the viewing server. Now it's going to hit this proxy, and the proxy is going to route that connection from a trusted port to that particular streaming session. And then the client will be communicating directly with each particular streaming session. So likewise, client 2 will follow the same path. It will connect to the web application server. The required model will be pulled out of model storage, and then it will communicate through the proxy to that particular streaming session. Now, the one thing to note here is that the proxy application is not provided by Communicator. This is an external component, and you can use any proxy that you want in order to facilitate this workflow. So the final mode we're going to talk about is viewer standalone. And in this mode, you can see it's a pretty simple diagram. So this does not use our server application. It is simply starting up the individual streaming application itself and directly connecting to it. So this is a use case that can be used if you have, say, a desktop application that needs to connect to your streaming session. For example, if you have like Qt that's running a web view or something along those lines, you can spawn this streaming session directly You configure it via the command line by telling it what port you want it to listen on, and then you can directly connect to it. In this mode, you still have to make sure that the model is available for your streaming session, but this allows you to have full control over the startup process of the viewer. So if you have specific needs in that you need to launch it in a certain way, you can use the viewer standalone mode in order to facilitate that. So I do want to talk a little bit about load balancing. So much like the proxy, load balancing is external to the Hoops Communicator application. The viewer servers are placed behind the load balancer, and it's going to handle distributing connection requests to each viewing server. So this is important that your viewing servers are independent of each other in the sense that each one can access the model storage individually, because the load balancer is going to fan out those connections to any random viewing instance. So one thing to note here for the load balancer, we can route the machines based on location. So since we're doing live streaming, that's one thing we want to keep in mind. We want to get users to the closest viewing server we can. So for example, if you have a viewing server in the US and one in Europe, you can configure your load balancer to route US North America traffic to the one in the United States, and European traffic to your server in Europe. And this allows you to add or remove nodes transparently to the caller. So you can respond to demand by adding more viewing servers, and in times where demand is not high, you can remove them, and the load balancer handles all that bookkeeping. So an example of this is the Amazon Web Server Classic Load Balancer. We also use the AWS Application Load Balancer as well, because it has improved support for WebSockets. And then a little bit more about the proxy. So by default, every time you spawn a viewer process, it will listen on a non-standard port. So for example, we can listen on port 11,000. And what we want to make sure is that all our communication with the outside world is done through standard ports, for the reason being that corporate networks usually do not allow access over non-standard ports. So the proxy here is going to handle that case for us. So it's going to listen on a standard port, and it's going to route traffic to that non-standard port on our own machine. And any URL rewriting that needs to be performed will have to be handled by